Okay, so in this video I'm going to show you how to do an inverse matrix of a 3 by 3. So to start off, I'm just going to give a random matrix. Say 7, 2, 3, 1, 0, -2, and 3, 5, 6. Okay, so there's my matrix. See. Okay, so now what we're going to do is we're going to do something called matrix of minors. So what we're going to do is we want to isolate this variable or this cell, and we're going to cross off. Okay, so we have row 1, column 1. So what we're going to do is take off row 1 and column 1. So we're going to do invisible lines. So we're going to do that and that. So we're left with a 2 by 2 matrix. So next to this, I'm going to write what my matrix was, and I have a 0, 5, -2, 6. I'm going to draw the determinant lines next to that. That's going to be one part. And that is going to equal my dotted here. And that's going to be my first cell. So now what I'm going to do is do the same thing, but do it for the second one in this column. So I'm going to dot this one. And I'm going to do the same thing, but with column 2. So we cross off this row. And if you can imagine a line going like right here. Hang on. Like that, you'll see that I have 2, 3, 5, and 6. So this is going to be my, right here, 2, 3, 5, oops, sorry, 3, 5, and 6 lines. And that's going to represent my dotted cell over here. So basically you're going to do this until you have each and every cell. So let me just continue with this. So again, you're going to cover up this because it is this dotted. So you have the 3 dotted. So what you're going to do is cover up the row and the third column, which is going to be right here. So you're going to end up with, hang on. So you're going to end up with 2, 0, 3, and -2. So you're going to write 2, 3, 0, and -2. So now you got your first 3 cells on the top. And again, this is called matrix of minors. So now what we're going to do is do the second row. Dot this. So what we have here is the 2 that's dotted. So now what we're going to do is use the close off the second row and the first column. So it's going to be, this is 2, hang on, 2, 1. So second row, first column. So if you can imagine, we have the second row here, first column. So you're going to have the 2 on top, 2 on the bottom. So that's going to be a 1, 3, -2, and a 6. So we're going to do the same thing. We're going to dot the 0. We're going to have row 2, column 2. So it's going to be a 7, 3, 7 and a 3, 3 and a 6. Okay, so now we have the last one, which is on this row, which is a 5, and that's going to be, we have here, so this row, this column, and that is going to be a, this row, or sorry, this column, this row, so it's going to be a 7, 1, 3, -2. 7, 1, 3, -2. So now we have our second set of cells. So now we're going to go to the last set. We're going to dot the 3. Say, okay, so this is the 3 by 1. So we have row 3, column 1. So it's going to be the top 4 on the right. So it's going to be 1, 3, 0, 5, and then we're going to have this row, this column, so then it's going to be a 7, 3, 2, 5. So now what we're going to do is we're going to have this row and the third column, so it's going to turn into a 7, 1, 2, 0. Alright, so now we have our matrices of minors. Okay, so now what we're going to do, so when I drew these lines, not the matrices lines which look like this, they're little brackets. What I did was I just drew a straight line down. And that's going to make it so I know I have to find the determinant. And if you don't know, for a determinant, it's do off to the side here. It's going to be, you have variables A, B, C, and D. So what you're going to want to do is you take A and D, you're going to multiply those. So it's going to turn out A times D minus the values B times C. So I'm going to use that, and that's in a determinant for a 2 by 2. I'm going to use that for my determinants here. So the first one, 0 times 6 is 0 minus negative 2 times 5. That's negative 10, negative 10. So 0 minus negative 10 is 0 plus 10. So my first number is going to be 10. My second, 2 times 6 is 12 minus 15 is going to be negative 3. We have 2 times negative 2, it's going to be negative 4. Minus 3 is negative 7. I'll draw a little line to separate these. So now we have our first line of cells. 1 times 6 is 6. Minus negative 6, so that's basically 6 plus 6, or 12. Then we have 7 times 6, which is 42, minus 9, and that's going to be 33. Then we have 7 times negative 2 is negative 14, minus 3, that's going to be negative 17. And you want to get all these numbers right, because if you mess up one number, even just one little number in this, it's going to get the entire thing. Your answer, everything is going to get messed up. So you want to be completely accurate on this. So then next you're going to do 1 times 5 is 5, minus 3 is 2. Then you have 7 times 5 is 35. Right here, 7 times 5 is 35, minus 6, you're going to get 29. And then 7 times 0 is 0, minus 2 times 1, which is 2, so negative 2. Okay, so this is my matrix so far. I'm going to draw little arrows. Okay, so now what we're going to do is something called the coefficient matrix. And the coefficient matrix is basically changing some of the signs of the negatives and the positives in the matrix, this matrix. So what we're going to do, I'm just going to write it out quick. You have a positive, negative, positive, positive, negative, positive, negative, positive, negative. So this is what the matrix of coefficient looks like. Oh, hang on. There we go. This is what the matrix of coefficient looks like. So basically what the plus and minuses mean are a plus is going to mean do not change sign. And a minus is going to be make the sign the opposite of what it already is. So a negative 17, if it is the negative spot, which it will be, a negative times a negative is just going to be 17, or a positive 17. So stays the same. Okay, so we're going to apply the matrix of coefficients to this matrix right here. So I'm going to go down here now. And I'm going to have, so we have this. So we have a plus and the 10, same position. Sorry, I have a bit of a cough. We have the 10 and the plus. So that's going to mean the do not change sign, and it is a positive, so it's going to remain a positive 10. Now we have a minus here and a negative 3. So what we're going to do is, oh, sorry, I messed up on this. The negative is just the opposite. Okay, so it's a negative times a negative 3. So basically, a negative times a negative is a positive. So we're going to have negative 1, basically, so negative times negative 3 is going to be positive 3. A plus for negative 7, we're just going to keep it the same. Then we have a minus for 12, and it's a plus. We're going to change it to negative 12. Then we have a plus for 33, and that's positive, so we're going to keep it the same. Then we have a minus for negative 17. So what we're going to do then is change the sign to positive 17. Then we have a plus for 2, so it's going to stay the same. We're going to have a negative for 29, so we're going to change it to negative 29. And we have a plus for negative 2, so we're going to keep it at negative 2. Okay, so this is my matrix after the matrix of coefficients right here. So what I'm going to do now is, it's a technique where, so I'm just going to draw it quick. You do a diagonal. My numbers aren't perfectly lined up, so this is why it's a squiggly. But so what you're going to do is the 3 down the middle, and that's what your sort of circle thing is going to look like. So what we want to do is take the same numbers on every side and switch them, basically. So you see, here's negative 29, and here's 17. They're on both sides of the little squiggly circle sort of thing. So what we're going to do is we're going to switch them. Just flip them around. So 17 is going to go down here, negative 29 is going to go up here. And that's going to be the same thing for all of them. So I'll just draw that quick. So that's what the switching is going to look like. So your new matrix, after you switch, is going to turn out to be the circle, or the squiggly circle, whatever you want to call it, still stays the same. So we're going to have 10, 33, and negative 2. So now we have to switch. So 17, negative 29, switch those. So I'm going to have 17 where the negative 29 is. So 17 and negative 29. Then I want to switch the 2 and the negative 7. So what I'm going to do is put the negative 7 on the bottom and the 2 up here. Then I'm going to switch the negative 12 and the 3. So the 3 is going to go right here, and the negative 12 is going to go right here. Okay, so once you got that, what you need to call this, or this matrix, once you flip them around, this is called the adjunct matrix, which is abbreviated ADJ. I'm going to spell it out right here. It's ADJUNCT, adjunct. It's like you're saying junk, but with a T at the end. Anyway, so that's how it's abbreviated. So we're going to use the equation A inverse, and what the A is our original matrix, which is up here. So what we're going to use, A inverse, the inverse of our original matrix, is going to be 1 over the determinant of A times the ADJ, or adjunct matrix. So right now, once we have the adjunct matrix, which is right here, we need to find the the determinant of the original matrix. So I'm just going to get a new piece of paper. And I'm going to say our original matrix was 7, 1, 3, 2, 0, 5, 3, -2, and 6. So this was our original matrix. So what we can do now is a technique I like to call the diagonal. So basically what you're doing, because before I showed you how to do the determinant of a 2 by 2, which was the A times D subtract B times C. So a 3 by 3 is different, obviously, because it's not a 2 by 2. And so what we're going to do is we're going to take the first 2 columns, so this one and this one, and we're going to rewrite them in order on the side. So this column is going to stay here, but it's also going to shift over. So we're going to have 7, 2, 3, and we're going to rewrite the middle column as well. So 1, 0, -2. So now that we have our 2 columns written, our first 2 columns written here, what we're going to do is we're going to, because there's a diagonal for each one now, of a diagonal of 3, we're going to use those and add those up. So here, let me show you what I just meant. So I'm going to use different color highlighters. So we're going to take this row, hang on, the 303, and we're going to add those up quick. So we're going to do 3 times 0 times 3 plus, and we're going to do a diagonal for each one. So we have -2, 5, and 7. Times -5 plus the 6, 2, 1. Okay, so now what we're going to do is add those all up together. So we got 3 times 0 is 0, times 3 is 0. Plus, you got your, you have your -2, sorry, this is not a -5, this is a just +5. So you have your -2 times 5, that's -10, times 7 is going to be -70. Then you got 6 times 2 is 12, times 1 is 12, so you're going to say plus 12. Let me do that real quick. That's going to be -58. So this is what you get going up. So now we're going to do, in a different color of highlighter, we are going to do the diagonals, but going the opposite direction. So we're going to do the 706, and that's going to be 7 times 0 times 6 plus, which one is it? The yellow. We have the 153 plus 1 times 5 times 3 plus the 3, 2, -2. Okay, so we got 7 times 0 is 0, times 6 is 0. Plus we got 1 times 5 is going to be 5, times 3 is 15. Then we got 3 times 2 is going to be 6, times -2 is going to be -12. Add that up together, you get 3. Okay, so there's something I like to, there's an order you have to subtract them in. So I like to call it down minus up. So if you look at it, you can sort of see the yellow, if you're looking at the yellow goes down in a sort of perspective, and the orange goes up. So I'm gonna say down minus up So we're going to take the down, which the down we just did, and that was 3. So we're going to do 3 minus, then our up, which was the orange, is negative 58. So we're going to go negative 58. And adding or subtracting a negative is the same thing as adding a positive. So you can look at my other videos to see subtraction and addition with positives. So what we're going to do, so this is changing it. So 3 plus 58, that's going to be 61. So now our determinant of the 3 by 3 matrix, which was our original, or A, right, that is the determinant of A. DET. Determinant is abbreviated DET in parentheses. So now we're going to use the equation inverse of A equals 1 over the determinant of A, which we found was 61, times the ADJ. And I'm just going to do this quickly on my calculator. If you have a TI-84 plus silver edition, how you're going to do is you're going to have it on, and go alpha, zoom. It's going to bring up this menu. You want to go to a 3 rows, 3 column, press OK, and you're going to say our ADJ, which bring the next piece, our old piece of paper. We had 10, negative 12, 2, 3, 33, negative 29, negative 7, 17, and negative 2. So that was our ADJ, or adjunct matrix. So we know we have to do that times 1 over 61, and that'll give us our inverse of our original matrix A. So now what we can do is you're going to press this button. It has X with a -1. You're going to press that. Oh, actually, I don't want that. I messed up on that. Sorry about that. Delete. So I want times, we're going to do A, or alpha y equals that. Do 1 over 61, which was our determinant of A. Multiply that, and the calculator will automatically do it for you. And that's your answer. So that is how to do a inverse of a 3 by 3 matrix.